So one, this is the component called capacitor. We have earlier said a capacitor is just a device for storing charges or storing electricity. The setup is that it consists of two conductors, two metal plates. They are conductors and call them metal plates, and they are carrying opposite charges. You see, like this diagram tells you that it's carrying a positive charge while it's carrying a negative charge. Now, these two plates are not placed side by side. There is a distance between them, and there are sometimes you can choose to separate them with an insulator. You can separate these two distance of this conductor by an insulator. This insulator is what we call the dielectric substance. The insulator, the conductor rather separated the insulator called the dielectric substance. Now, this is the symbol of a capacitor. Now, to charge your capacitor, you have to connect it to the conductor to a power source, like a battery or a cell. Now that you have set up your capacitor, the next thing we want to discuss is capacitance of a capacitor. Now, capacitance of a capacitor is denoted with capital letter C. What is capacitance of a capacitor? Capacitance of a capacitor is just the ability of the capacitor to store charge. How much can a capacitor store charge on its place? You are set it up, but you are not checking how much charge will that capacitor be able to store. So the ability of the capacitor to store charge is called the capacitance of the capacitor. Now, you can also see it from another angle. Capacitance of a capacitor is defined as the ratio of charge to the potential difference between the points. It is defined as the ratio of charge on either plate or conductor to the potential difference between across the two plates. So that is to say, if you know the charges on the plates and you know the potential difference across the plates, you can go ahead to get your capacitance of your capacitor. Or if you are giving your capacitor of your capacitance, the capacitance of your capacitor, and you know the potential difference that is supplied by the cell, you can go ahead to know the charges across the plates. But the idea of capacitance of capacitor is just to know how much charge a capacitor can store in space. But if you have a setup of a capacitor without even putting a potential difference, without even allowing the charge to start sending out charges, how do you go ahead to know the capacitance of the capacitor? It is given by this formula. C is equals to epsilon naught times epsilon r times area times d. With this formula, you can get the capacitance of the capacitor. Without even connecting your cell to it, you can get the capacitance of the capacitor. E naught times E r is equal to E epsilon, which is the permittivity of the medium. It just tells you how much that medium can hold charges. Because we say you can place an insulator between the two plates. Now, that insulator depends, is a factor that capacitance depends on. Now, that insulator you are placing in between the two plates has what we call the permittivity of the medium, that is epsilon. How much can the material hold charges? How much can the material hold charges? While E naught is just the permittivity of free space. It is a constant given as this, 8.85 times 10 raised to the power 12 farad. And please be careful, the unit of capacitance is farad. It is denoted by capital letter F. So we are saying E naught represents permittivity of free space. It's a constant. Anytime you want to do calculation, the value is 8.85 times 10 raised to the power minus 12 farad per unit meter. Now, E arrow, this E arrow, epsilon arrow, is what we call the relative permittivity of the medium. the relative permittivity of the medium. It is just comparing how much can that material hold charge with respect to a vacuum. How much can that material hold charge with respect to a vacuum, and comparing it? How much can this material you are using here now? How much charge can it hold compared to how much charge it can be held in free space? While A is the area of each plate. The area of the plate stands for A. While D is the distance separating the two plates. How far is the two plates from each other? Once again, we have two formulas for capacitance of the capacitor, which is this and this. This one helps you to really solve the capacitance of the capacitor without even connecting, knowing the potential difference. Once you set up the material, you know the area of the plate, you know the distance, you can know the capacitance of the capacitor. But when you are relating capacitance of the capacitor with how much charge it can hold and the potential difference across the plates, you relate it to this. So what we want to do now is to go ahead to calculate capacitance of the capacitor. Once again, the capacitance of the capacitor, the idea is how much can the capacitor hold charges if you are giving a certain potential difference from your setup and you are giving a potential difference. How much charges can that capacitor hold?